G'day Bifrosters. So here you can see we've got a scene. It's a Bifrost scene. And there's a skull in it. And some lighting and all that kind of cool stuff for rendering as well. We're going to scatter some stuff on the scene. As you can see, I've got a small file setup. Alrighty, we're not going to be talking about most of this because most of this is just getting the background sorted out. But we are going to be doing a little bit of advanced scattering and well, instancing rather. We've been talking about scattering for a while. It's time to put some instancing into the mix. We've got this delightful little canyon with a very repeaty rock texture on it. There we go. We've got our skull. I've got a bunch of stuff. Let's instance some things and scatter some things on this. So first off, what I'm going to do is I'll show you what I've got set up already. So I have a strand. Now the strand is coming in from here, which is edge curve shape. And what that is it's the edge of one of these moved into the middle. So we can actually take a look at that just by chucking down a terminal. Let's have a quick look at that. So there you go. So we've got our background, well, we've got our background object set up. It's literally a plane and some volumes. Basically just a quick and dirty shader that I've done some noise work on just to get the edges looking right. It's nothing fancy. It's just something that I can show you with. And so then I've made this strand, and using our scatter around strand, I'm going to put some points on it. There we go. There's a lot of points, and they're all floating around in the air. They're not being all that helpful right now. So what I've done there is I've just raycast those down onto the light brown ground. So let's put in another terminal. Get rid of that. Not a terminal. Terminal. So I'm going to turn off these guys. So there you can see, there's my scatter around strand. It's filling that canyon nicely. So scatter is all well and good, and we've come up with some good additions to the scatter pack so far. It's time to sort of put them into practice and just take a look at a little bit more advanced instancing, really. So I'll break that. I don't need to break that. So I'll turn that off for now, but as you can see, I've really just scattered these points within the bounds of the canyon, or the fake canyon. They're sort of sticking over a little bit, which, you know, if we really wanted to, we can fix because we've got all of these controls in here. So, you know, I can change my max radius, so we're just bringing the points back in a little bit, so we've got more of a density going up the middle there. You can take a look inside as we do it. You can just see the points are just, the max radius is just sliding in. So now we've got this horrible gap here. So we'll take this back to about 2.4, which will cover the canyon, because I mean, I could do some fancy stuff like, you know, check to see if the point is inside the SDF, and if it is, then get rid of it. This will do for now. I mean, yeah, close enough, right? And when you guys come to sit down and do something like this, or pull this file apart and take a look at it, then you can do something better for your own. But anyway, so those are the points, and this is kind of important. This is what all instancing depends on. Now, you've all seen instancing before, I hope. Perhaps not. But the other thing I need to show you before we go ahead and do the instancing is I've got grass, mushrooms, dandelions. These are my scattering objects. And they're actually arrays. They're arrays of objects. And if you want to take a look at them, we can turn them on. And they look like that. So there's my grass, and that's actually a whole bunch of different clumps of grass. And then I've got the same kind of thing going on with mushrooms. So just a bunch of different mushrooms, and then dandelions, as you can see. So these are just to give us a bit of variation. Yeah, so we can use these as arrays, or we can do what I'm doing and just grab one object from the array. And I want to show you a couple of things. So let's hide that again. And show everything, and we'll just get back. This is why I make camera bookmarks, so we can quickly get back to it. So the first thing I'll show you is, what if I wanted to scatter grass on this? So let's turn our points off for now. We know they're there. And I'll just plug in this create instances here. I'm just going to plug this straight into the output. So we're going to do a little crash course on instancing, but that's okay. So plug that straight into the proxy and give it a second, and there you go. It's scattered a whole bunch of grass onto this object. And you can see where the points start to peter out, that they are literally clumps of grass. Right now our selection mode is set to none, which pretty much means, if we check our info, selection mode none assigns the first shape to all instances. So that's essentially taking the first in this array and assigning it to everything. We don't really want that if we're going to instance some grass. We're going to do some different things later, but for now we're just looking at instancing an array. So I can change that to sequential, which means it'll alternate. It'll go the first in the array, then the second in the array, and the third in the array. And when it gets to the end of the array, and I believe there's 5 or 6 in here, 1, 2, 3, 4, 5, 6 of them. So when it's done the 6th one, it'll go back and do the first one again. Or we can just go random, and this just gives you a bit of a breakup, bit of a different look. Now, this is quite heavy. There are quite a lot of points here. 10,000 points being scattered, and they're all having this piece of grass scattered on them. So that's all good, but a little heavy. A couple of ways to fix that is we can go to a scatter and drop the number of things we're scattering, and that's a bit faster, but also things are getting a bit patchy. I'll go back to 10,000 just because I like to look better. And the other thing that's going on is that all of these are very, very similar. They're different clumps of grass, but they're all the same scale and they're all oriented the same way. So we have a couple of nodes to help us with that. We have randomized point rotation and randomized point scale. Now if I plug these in and you watch what happens to the grass in a minute, there we go. Suddenly it looks a lot more natural and a lot less repeating. And you can quite happily change this. So this is just rotating in radians around X, Y, and Z, minimum and maximum. Change the seed, and you get a change. And this is randomizing the scale from 0.4 to 1.6. So if I start to pull this up, you can see the grass is growing upwards. Go back to 0.4. And the same if I pull this down, it's shrinking. Pull it up. So you can get quite a lot of really good looks really, really quickly with just one of these doing its thing, which is great. So that's the basic run through. The other thing you can do is set a probability curve, which is an F curve. So if you remember when we talked about F curves, what F curves are is that the input is the X and the output is the Y. So what this means is that if you think of this to be all of the things in the array, we're getting the same number in as we're getting out. Just to pull this up a bit, you can see the array starts to change, and it's changing what it's instancing. So if I go to 1, it's just instancing the last one. And if I take that back to 0, and then I can change the curve preset, that way you're going to get quite a bit of the first one, normal values in the middle, and then quite a bit of the last one as well. So it's simple F curve. It works how F curve works. You can get all kinds of looks that you like with your F curve, which is all good. And that is the basis of instances. You can also change the random seed and get a different look again. So yeah, that's the basics. And I don't have to just scatter the grass array. I can also chuck in the mushroom array like this, and then you can see I've got a whole bunch of mushrooms. Now maybe I've got too many mushrooms there, so if I was to pull this down, quite as many mushrooms like so, which is quite fiddly. and difficult to do. Go to 0.6, no, we'll go to 5.8. We'll go to 5.6. There we go. So, I'm just controlling how many mushrooms are showing up with this probability curve. I can also drop this a bit more. Let's go to say 0.25, but then we'll bring this up a bit. So you can see I can make reasonably accurate curves, reasonably fancy. And again, I could throw in another array. I could throw in my dandelions as well. But this is where we start to move on to some of the other nodes that will help us do this. So I'm just going to pull my mushrooms out of there, bring it back down. So right now this is just scattering a grass array. Okay, six different sort of bunches or little blobs of grass. You can kind of see them there as they turn up. And it's choosing them randomly, and it's got a probability curve, which I'll now reset because I took the mushrooms out. The other thing we've got with instancing is we've got a mask weights. And the mask weights works like everything else, like the instances mask weights, like all of the other things we've seen before. And down here, I've got a little field set up here. So this is a sphere field. And what a sphere field does is it makes a scalar field whose value at any position is the sign distance to the surface of a sphere. So outside of the sphere is positive and inside of the sphere are negative. So right now I have a sphere field with a radius of 0.3 that is based on the center, or the centroid rather I should say, of our skull here. Which means if I plug in the sphere field into my mask, and you can see what that's doing. That's clearing some space in a spherical area around the skull, around the center point of the sphere. And I've also put a mask field on it, which quite simply takes any value that's positive and makes it 1, and any value that's negative or 0 and makes it 0. So that will give me a much harder line. So if I do this, you can see the sphere turn up. Boom, like that. There's the sphere centered around the skull, which I'm going to deselect. So there you go. And of course I can change the radius. And I can kill more of the grass around it, more of the instances around it. Or I can do this one here, which I've taken a value of 1, made it into a scalar field, and then subtracted this field from it. And what this is going to do is invert the field. So now you've just got that field there. And again, if I plug the sphere field in, and maybe pull in the radius a bit. So what's happening there is this is masking to 0 to 1. This has all kinds of values that go kind of all kinds of ways. Plug in this back in. Do that again. So now we've just got a little bit of grass that's essentially sitting around the skull, and then if we don't invert it, at the moment it's inverted like this, then we've got a hole. You can see how that works. So this works just like the instancing weights basically. If we check the info, it's the probabilities that a shape will be instanced at each point. So it's just the same as when we were culling our points in our scatters using the mask weights, or using the density weights, I think it's called, in scattering. Yeah, density weights. So cool. So there's another tool, and that doesn't have to be a nice sphere. That can be a big chunky fractal. So suddenly you've got this really nice sort of organic looking clumps of grass turning up. And you can of course combine that with this field as well. so that you have this inside that sphere if you want to. There's all kinds of nice math-based things you can do with fields, which is awesome. So that's the basics of that. We've got our masks, we've got an instance ID override, so we can override an ID if you take a look at down here. I'm going to go through this real quick before we get on to the more advanced stuff. Connect an array of long values containing the shape indices to assign per point. This gives direct controls over the shapes assigned. Which means I could make an array, the same number of points. I could then set up an array of long integers that were all 1, that would force this instancer to use the array index 1 in its instance geometries, which in this case would be the second in the array. Or I could set up a randomization that way too, if I wanted to, just by doing some arrays. And then you've got preview geometry, which means if I wanted to put in something like, well, I can show you. I could turn that into a bounding box, and that would show me very, very quickly where all my grass is. So that's just the bounding boxes. It's all good. And it's, essentially just showing me without having to draw everything where all my grass clumps are, which is great. Or I could put in a very lightweight piece of geometry into here and have it show me the preview geometry instead. At the moment, because there's no preview geometry, it's showing me the instance geometry. But this is just a way to get things sped up while you work. You can see that it's a little less reactive now. So, back to our scattering. So if I want to have grass, sorry, well now I've just got mushrooms. That wasn't what I was supposed to do. Let's plug the grass back in. So if I wanted to add mushrooms to that grass, I could pop that in there. There's some mushrooms, quite a few actually. If I wanted to have dandelions as well, I could pop that in there. And these are all arrays of different dandelions and different mushrooms. And things start to get pretty crowded pretty fast. You've also got things like dandelions are growing through my skull, which is not really optimal for me. And you've got gaps in the grass, and you've got mushrooms that are interpenetrating, and you've got all kinds of stuff. Now I could fix a bunch of this by changing my scatter to a blue noise, which would give me a bit of space around each point and make it a bit more regular. It would also take a lot longer to calculate. So, meet the randomized selection by probabilities node. So we just need to do a little bit of setup here. So I've got another instancer here. Let's just plug this in. So right now this is just showing me where the points are. It's instancing a default geometry, little spheres with some normals on them. They look like they've got some normals on them to me, because I haven't given it anything to instance yet. So for this one, what I'm going to do is I'm just going to get one of the grasses from the array. I'm going to get the second one, index 1. I'm going to plug that in. Okay, so again, sometimes you have to unplug it and plug it in again. There we go. It's now working. Now this is the same clump of grass, and that's for a reason. This is set to none, and that's fine. This is going to default to that clump of grass, which is fine. I've got some good randomization on my rotation and scale. So I don't think it looks too bad. And if, let's say, my camera was something like that, it would be absolutely fine. It would even be fine if my camera was something like that. Essentially, I'm taking a look at it and I'm going, that doesn't look like it's tiling. Maybe a little bit there, but we're going to be fixing that in a minute. So we're just going to use one. We're going to use one of each. And let's go and put in our mushrooms into the geometries, and then hopefully some mushrooms will turn up. Oh, no, mushrooms won't turn up because I've got this set to none. And then same with the dandelions. So we have our grass, our mushrooms, and our dandelions. At the moment it's just scattering our grass. If I change this to random, I'm going to get very quickly, which is nice, I'm going to get a mixture of all three. Sequential is going to do it sequentially. None is what I want. we'll plug in this node, which is randomized selection by probabilities, which pretty much does what it says. So let's just pop that in there and see what we've got. Now we've got something interesting. We'll pull that out of there for now. We don't need that just yet. So what we've got here is, let's just reset that. So this is the probability of each of these showing up. So at the moment we've got a probability of 0. 0, and what's our first one? Our first one is grass. Why is it still showing grass? It's still showing grass because this is set to none. And it's pushing through the first element in the array, which is grass. So if I was to add that, there's a 100% chance I'm going to get a mushroom. It's probably a bit too many mushrooms, unless your shop calls for a lot of mushrooms. So at the moment, if I change this to 0.1, I'm going to get all the mushrooms because right now I've got 0 probability of grass. So as soon as any of these leave 0, it takes over from here, as far as I can tell. So let's give it a 0.5% of grass and a 0.05 of mushrooms. So now you can really, really quickly control how many mushrooms you've got on your grass. That probability goes to 0, you're just going to get mushrooms. But if it goes to 1, you've got grass. You're guaranteed to have grass. And then you can add as many mushrooms as you like. We can do the same with dandelions. See them turning up? We'll get very few of those because I didn't do a very good texturing job on them, more or less. So now, using this, you've got a nice little field of very green grass and very brown mushrooms and all of that kind of thing. And what I wanted to talk about is we're going to use some weights in here. So we're going to do the same thing. Let's get our sphere going on. So as you can see, what this is controlling is where this is going to scatter its probabilities. So in this case, we've got it in a sphere around our dino. Let's change that to be everywhere except in that sphere. You can see we've got clear space around our skull. I can still change these, and I'm still going to get more mushrooms or less mushrooms, like so. I'm still going to get more dandelions or less dandelions, like so. And I'm still going to get more or less grass, as the case may be. So this, no matter what you plug into it, is still controlling the ratio of 1 to 2 to 3. And this is where we can do some cool things with either that kind of thing, or we can plug a field into it. And because it's a fractal noise field, we can do things with the magnitude that is nice, we can do things with the frequency that is nice, so we can get, again, our nice organic clumps of things that are then controlled by this guy, which is fabulous. I mean, this is already looking way more natural just from plugging a fractal noise field into it. You know, I could get real sharp and hard, and I can put in the mask field here, plug that in. So now you're going to get very discrete clumps. Turn our frequency down so we can get some big clumps. There we go. And that's already looking a lot more naturalistic than just doing something like this. And even masking that. See, that's masking the entire instancing. Full stop. That's the weights of where we're instancing on the points at all. So very, very quickly and very, very easily, you can get something much more natural looking by using randomized selection by probabilities, which is honestly one of my new favorite nodes, especially for scattering. And just to show you if you think about what this does, is this makes it a binary. So the mask makes it on or off, which is cool. You can see the difference if I plug this in. You still got the fractal, you've still got the clumps as they were, and you can still change the frequency, kind of thing, and play with all of the good stuff that you get with the fractal. Kind of idea, but the mask makes it a more binary proposition. It's either on or it's off. And again, it's very, very fast, very, very responsive. Let's push these frequencies up a bit, so we've got something like that. And then, of course, let's combine these two. So at the moment, that's what the field looks like. We're cutting a hole. I need to multiply, because they're all zeros and ones. Multiply those two together and see what we've got. So now that's the fractal here, and if I push my frequency up, you can see that working. That's the fractal just providing the information inside of our circle or sphere field. And then if I change it to that one, that's going to be the fractal with a hole cut out. So we can massively, we can bring the probabilities of these up and up and up and up. They're never going to touch inside of here because we're masking it out. Okay, so that's pretty much everything for instance IDs, and that's how this works. And it works on the instance ID property, which is on the point component. And of course you've got random seed to control your scatter. Set that to 0.1 again, we'll get this to even less. No matter what we do, the mushrooms and the dandelions are not going to come inside of this sphere because we're using it as a mask. So this is a really good gateway to not just instancing and doing very, very interesting instances stuff. It also allows you to play with fields. So for example, one of the other things I would be looking at doing here is I want to get rid of any instances that are inside of this volume or inside of the skull. And the way I would do that is I would turn the skull into a volume, and I would then use that volume as a lookup for the points that I'm scattering on, which are way back here. And I would basically say, like, I would check the voxel sign distance, and I would say, well, if you're inside the mesh, which I believe is negative, well, I always get that mixed up, it could be positive too, it's a 50-50 chance. Let's have a real quick crack at it. So here's the skull down here. Mesh to level set. And it doesn't even have to be all that accurate. And I would need to sample that volume all the way out here. So it looks like I couldn't do this on the points actually. I'd need to do it on there, which is the sample data. So that would become our position. This would become our volume. And the property we would need to use would be voxel sign distance. So now turn our instancing back on. Just for now, I'm going to get rid of this randomized selection. There we go. So now this is getting the volume samples. And obviously this is not a very high resolution volume right now. We can take a look at it if we like. Let's put this level set out. There's the level set there. And you can see that it's affecting the scattering around it. So I could make it a little bit more high res. you could see these points just pop back in. Maybe do that again. And you can see more grass pops back in. And if we wanted to do the same thing as we did with the fields, then it would just be a matter of so this is greater than 0. So what we do here is like if and for our true case, it's greater than 0, let's make it 1. If it's less than 0, let's make it 0. Plug that in. What that's going to give us is essentially a threshold. So now if I go back to my level set, push the resolution back up, now you can see the level set there. Let's just turn that off for the moment. But now that's giving us a more accurate representation of where the level set is, and it's destroying all of the instances around it. And of course, if I just unplug this for a second, let's plug that back in. We'd need to plug that into the weights here as well. There we go. And once more, change the probabilities here, and it's all very happy. But because the weights, and you notice that it's not a field now, it's just scalar float values, because that is the nice thing about these ports, is you can plug a field, anything into them that can be construed in any way, shape or form as a float. So scalar fields, float arrays, single floats, all kinds of stuff. But now, what I'm trying to get across, what's going on here is, and what's important to realize, is that if I delete that now, it all comes back in. It needs both of these to work. If I delete that one, same thing. So the weights control where this happens. The numbers here control what it looks like. You want no mushrooms? You can have no mushrooms. There you go. But it's not going to touch where the weights are. So it's not going to touch here at all. Alright. So that's just a bit of advanced instancing, really. I hope it was useful. And of course, we can, if you really want, we can go ahead and render this. So let's just switch this to Arnold. It's Arnold already. We'll just render it. Give it a minute to sort out its life. And you can all giggle at just how horrible my textures are. And then, you know, we can also completely forget to plug it into the right thing. Let's plug it in there as well. That's because I actually do want to render my instances. Thank you. And you'll have to excuse the horrible slowness of my machine, but you can see this talks to Arnold too. And I haven't baked these. These are still instances, they're not baked geometry. I'm just rendering straight out of Arnold with my textures from 1998. They may be more like 2004 in that there's no specular texture at all, no bump map, no normal map, no displacement, nothing. You're lucky it wasn't a teapot. I had a skull lying around. I wanted to do something with it. So that's instancing and instance IDs. You can do a lot of this. Up to and including, you can, by using the ID override here, you could have a very specific clump of grass be replaced by a teapot or a foot or whatever it is you wanted to replace it with. The point I'm making is that you have a lot of control just by combining, creating instances, and randomized selection by probabilities, and then all of the things that the instance ID lets you do. Those of you that are familiar with particles will remember how much of a pain in the ass instancing was in Maya for such a long time, especially if you needed to get those instances back out to geometry. I have spent long nights writing scripts and running scripts that turned every instance into an OBJ every frame. That was a very long time ago. I've got to say, that didn't happen like last week. That was somewhere in the vicinity of 2004, I think, something like that. But yeah, this is just going to happily sit there and render, but you get the idea. By the way, if anyone's interested, my instances are from PaintFX. They're just single PaintFX strokes with all the tubes turned off. I've always liked that PaintFX grass. The grass clump brush was always good. Anyway, so that's instancing and instance IDs and randomized selection by probabilities. So I hope that's helped. And yeah, have a good night. See ya.